Fractions or ratios. Same thing. Ratio compares value. So what that means, it says how much of one thing there is compared to another thing. It's visual right here. This 3:1 says that there are 3 blue to the 1 yellow. 6th grade math is the first time that you guys are really expected to answer a question with 2 numbers. You cannot tell me the answer is 7. You have to tell me that 7 is compared to what? 7 compared to 2 is different than 7 compared to 15. It's all about this unit, how the numbers compare to each other. So the 3 ways to write it, you'll see here. First one. Second one, use the word 2. And the third one is a fraction. Now note all these little red lines. I tried to make it obvious which one was the best. Okay, so the fraction, that's where we're going to spend 99% of our time. We won't really deal with a whole lot of those. But do know that they exist. So the ratio, the whole point of why we learn about them is so we can scale them up, and we can also scale them down. We can scale them up and we can scale them down. So this 3:1, you can see has been doubled. That ratio, 6:2, would be equivalent, that's not up there, be equal, those are the same thing. We could again put another row down here, 9:3, 12:4, 15:5. So every time yellow increases by 1, blue will increase by 3. But we don't think about it as additive, we think about that as a multiplicative relationship. So here, your double number line. Okay, it's not the way to do it, but is a way to do it. Okay, 4 pounds of cherries, $22. So here's your number line. Notice that they have the same amount. So they're increasing, but one of them gets to 4, the other one gets to 22, so they have to be increasing at different rates. They are the same problem, but they're different rates. So how on earth are we going to figure that out? Well, what you're going to do is you're going to set up a little ratio. Okay, 22 cherries, 4 pounds. Okay, 4 cherries, I should have probably put pounds, but that's okay. Actually, I'm going to fix that. Pounds. Okay. And the idea here is you can, any way you want, I see it right here. Divided by 4/4. 4/4 is just 1. You can multiply and divide by 1 and not change the answer to your question. So 22/4 is just this situation here. 1, 2, like these were your blue, right? Okay. And this was your yellow. What you're looking at there, this ratio, is just one of these bars that has been scaled up. Exactly 4 times. Okay. All right. Now your question is going to ask, select the double number line that correctly labels the cost of 1, 2, and 3. Well, I would only look at that one right there. I want to know from 0 to 1, how much money did I pay? Because if I know that it's changing at the same rate, that shouldn't change. So if I take that 22, which is here, this is my 22, and this is my 4, I need to change that into just looking like one of them. And the way that I do that, well, is division. Because that ratio, you can say that out loud, 22 for every 4 would be the same thing, 22 divided by 4. Now getting your answer is a little bit of Unit 3 stuff. You can get that out of there now, right? It's Unit 3 stuff. You get 5.5, you have to make sure you get that 0 on there, because it's money. And that ratio just now changes to $5.50 for 1 pound. Those two things, 22 for 4 pounds and $5.50 for 1 pound, all you have done is you have set up a ratio, you have looked at it, You've decided what you want to do with it. And now you have your answer. Looks like it's this one. Right. 1 pound of cherry, $5.50. So the reason this works is your identity property of division. Well, like it doesn't matter, right? To summarize this, like I Googled it just to show you how like it's a scary thing, right? All that it means is that if you take 18 and you divide it by 1, then it's 18. So don't Google the definition. I did for you. That's all you need to understand. Okay? And you can take that and you can use it to help you. That would never help you. 2/3 times 1 equals 2/3. Right? Okay. 25 over 30 divided by 1. Like that's not going to help you. But you can do the exact same thing and make it look like this. And now you can tell that 2 compared to 3, 25 compared to 30. This guy is the same 2/3 as 10/15s. And you know that because of this right here. You are scaling it up. If you multiply, you scale it up. Essentially, you are putting 5 bars. 1, 2, 3, 4, and then you're counting them very quickly. And if you divide, guess what you're doing? You're scaling it down. So scaling up is nothing more than multiplying by 1. Scaling down is just dividing by 1. You end up with the exact same thing you started with. Right? Let's triple check. So 2 divided by 3 and 10 divided by 15. Cool, those are the same thing. 25 divided by 30 and 5 divided by 6. Look, they're the same thing. Okay, so I'm not lying to you. So, this will be important when you start working on your work. According to Greg, perfect cherry pies have this ratio. That's probably important because that's what we just learned about. So right off the bat, boy, I'm going to set that up. 240 cherries, 3 pies. That be my ratio. I'm going to make it look nice. Select 2 ratios that are equivalent to 6 out of 10. Well, that's a different problem. Wow. How many cherries does Greg need to make 9 perfect cherry pies? Well, you need to take this ratio and scale it either up or down, and I don't know, right? But we need to make 9. So there's the 3 pies. I don't need to know how many if it's 3, but how many? Well, probably 9. Turd. Put 9 right there. 9 pies. Okay. Well, now I have to figure out this part of it. Right in there. And that's where it always works, right? So 240 over 3 times something could give me something. All I really know is a 9 went there. Now I have to fill in everything else. That has to be a 3. 3 times 3 is 9. There's nothing else I can put there. That tells me that this number also has to be a 3. 240 times 3. I would honestly, I know my multiples of 12. I would think about that as 120, and I would double this to 6, and I would make that 720. 12 times 6. You can write it out. I don't want to. 720 into 9? Oh, well, shoot. You know what I also could have done there is I could have taken my 3, my 240. 3 goes into 240, 80 times. Better put a 3 in there so I don't forget that should be a 3, right? I'll reduce this. Now I have 80 over 1 times. Oh, that's a little bit easier. It's my answer. 80 what, though? I don't know. Well, Yeah, I definitely messed up. Right, we would take this right here. Sitting here trying to figure out what I did wrong because I don't want to record another video. That's your new ratio, isn't it? Because you took your ratio, 240 over 3. You made it exactly 1 times bigger. So yeah, you definitely wouldn't have wanted to do this. That was bad. Yikes. That's what threw me off. Okay. So how many pies would you need? What's your answer? Next problem. See if I can do this one any better. Wow. You're not multiplying, you're manipulating ratios. 2 that are equivalent to 6 over 10. Well, I also know that ratio could be represented this way. Okay, so this one I'm going to go up, this one I'm going to go down. So up means I'll have to make it a little bit bigger. 2, 3, 4. All right, this one I have to divide it. Well, and I can only use numbers that are both common to 10 and 6. I think it's really only 2. So let's see what we end up with here. 6 over 10 times 2 over 2 would be what, 12 over 20. Okay. 6 over 2, 10, right? We're just multiplying these by our common factors. So that's the times 2 over 2. The times 3 over 3 would give you 18 over 30. Okay, 4 over 4. You see what's happening here, though, right? We're just making it relatively 24 over 40. And then what? 5 over 3. And then, of course, it looks like some of those. Nope. Okay, cool. No. Yeah, we wouldn't be able to use that, right? Because that's actually flipped around. Phew. So those are your options here, right? We don't want to flip the 6 and the 10 around, because then that would be 10 to 6, right? Comparing a 6 to 10 is not the same thing as comparing a 10 to a 6. So anyway. Any of those two on there? 12 over 20, 18 over 30. Nope, that one's close, but I don't think that one's going to be right. Okay, so let's just start checking them then. All right, let's take our 6 out of 10 and see if we can figure out what has happened. Okay, so that would be a 32 over 50. I'll make it a little bit smaller. So, does that equal 3 over 5? Does that equal 24 over 40? And does that equal 14 out of 80? Well, it would if it either gets multiplied or divided by 1. Right, so that has to happen in order for them to be equal. So 6, well, I don't think that even goes into 32, but 10 times 5, so really 6 times 5 does not equal 32. So that guy's out. Okay, look at this one though. What's 6 divided by 2? 10 divided by 2. Divided by 2 over 2 would give you that 3 over 5. That one works. Okay. This looks like it's scaling up. 6 times 4.